Hello everyone, in this session we are going to learn how we can utilize gray relational analysis in order to rank out our performance criterions. Like in this case we have been given a set of hatchback cars and the performance criterions are price, that is given in INRs, then we have storage space, mileage and looks. So these three columns has been rated out of 10. So this video is a continuation of the previous two videos where we have ranked all these factors using Topsys and Westpac. In this case we would be using gray relational analysis. So starting from the first step, it would be normalizing the data. So for the normalizing the data we have to go either for the higher the better or lower the better. So in this particular case, for a price or INR we have to go for the lower the better, because we always want to have the lower price. So for that we have to calculate maximum and minimum of all the values. So we would be calculating maximum and minimum, so it would be used by the formula simply as done previously. Then we have to go for the max. In this way the max is calculated. Then we can select and drag it out so that we can have the maximum and minimum. So for the price we have to go for the lower the better, so it would be maximum minus that particular value divided by maximum minus minimum. So it would be equals to, first of all we have to take the bracket, then we have maximum minus that particular value, so it would be this, then divided by maximum minus minimum. So the first normalized data is calculated. So as we can see that the maximum and minimum is to be fixed, so we would be using F4 or $sign. So we are just fixing it so that other values can be calculated out. So in this way the values are fixed and the INR column has been calculated with normalized value. Similarly we would be going for the storage space, mileage and looks. So for these three we would be using the higher the better. So the formula for the same would be that particular value minus minimum divided by maximum minus minimum. So as you can see out, I have written down the formula, that is that particular value minus minimum divided by maximum minus minimum. You can verify it from here. So once I am done doing this, it would be done like this. Simply I would be dragging it out. So in the same fashion mileage and looks would be calculated. So as you can see it out, the normalized data for all the columns has been calculated. So then we have to go for the second step, that is determining the deviation sequence. So it would be 1 minus the value that we have calculated earlier. So getting into the Excel sheet, so the value would be 1 minus this much that we have calculated the normalized data as earlier. So it would be 1 minus this one, and in this way this value is calculated. We can drag this out like this. Similarly we can extend them to for all the values. So it would be like this. As you can see, it has been calculated. Then we have to go for the minimum and maximum, because in the third step we must have the minimum and maximum delta that we have calculated earlier, and in this case the zeta would be 0.5 because it has been used by the researchers considering the distinguished value for the GRA. So we would be following the same. So minimum and maximum is to be calculated, so we would be extending this in order to calculate the minimum and maximum. Simply it would be done like this. We will be just removing this because it has no data. So the formula for the gray relational coefficient would be delta minimum plus zeta or xi delta max, then we have the particular value, then we have the zeta delta max. So it would be simply what we have, delta minimum, so it would be this value plus 0.5 multiplied by delta max, it would be 1, then we have divided by that particular value plus zeta delta max. That particular value would be this much, we have to use bracket, and then plus what we have, zeta delta max. So the value of zeta has been considered as 0.5, so we would be writing over here, then we multiply it by zeta max, that is 1. In this way this step this value is calculated. As we can see that the maximum and minimum is fixed, so we would be just fixing it by applying the dollar sign or pressing the F4. So it would be fixed like this, and in this way all the values are calculated. So as we can see that for all the cases the minimum and maximum is 0, and minimum is 0 and the maximum is 1, and in if your calculation is right or correct, then it would be in between 0 and 1. So I would be just simply extending it in order to calculate the great relational coefficient. As you can see over here, the formula would be O10 for this particular value, so you can see it out, that is O10 has been taken in this particular formula, and all the other values M14 or 15 and 15, all these are in between are 0 and 1, so I have just fixed them out. Then we have to calculate finally the relational grade. So for calculating that, we must have the formula weight multiplied by the value that we have calculated earlier. So it would be simply weight. So what weight we are having, in this case we can see the weight has been calculated by equal weight method, that all the performance criterions have the same weight. So it would be, you can have the formula for this, it would be 1 by 4, or you can select it as 0.25 multiplied by the formula has a summation, so it would be summation of all values, so it would be this much, then this much, then this one, and then again the final one. So in this way what we can calculate, the grade relational grade. So as you can see that the relational grade has been calculated. Once the grade relational grade is calculated, then we have to calculate the rank, so it would be by the same formula rank, then we have to select that particular value, then we have to put comma for the reference value, so it would be all the values, and then we have to go for the descending order by pressing 0, and then we have to fix the reference in order to calculate the ranks. So it has been fixed, and in this way the rank has been calculated. So let's see, previously we have applied what we can say Topsys and VSPAS. Now we would be comparing all these values for all the three MCDM methods that we have utilized. Over here I have shown the ranks for all, so I would be just pasting this value also. So let me just paste it out, it was a mistake, and the values has been found. So you can, as you can see that there is some difference at level 1 and 2. What we can see, for these two the values are same, but over here the 1 and 2 is differing. So why these two are differing? As we can see over here, the difference between the grade relational coefficient between 1 and 2 rank is nearly minimal, or what we can say, it is in decimal, which is around which is least. So it becomes very what we can say hectic to get the values at this much differences. So one can go either for this or this one. So every MCDM methods have their own properties. So in this way we have got an analysis of all these three MCDM criterions. Over here we can say Topsys and VSPAS have the almost the same ranking, but in case of GRA we are having some difference, like at rank 2 and rank 1, and I think at rank 3 also, but it is due to a minor variation in the grade relational grade. As you can see for this one also, this one is 0.56 and this one is 0.58. Thank you.